Hi, welcome to Manufacturing Pathways Core 1. In this session, we're going to be talking about sandwich construction. So earlier, we talked about how cores are used. Cores are used to separate composite skins. We use lightweight cores. They separate the skins and they create rigidity, and particularly in bending. So because boats are dominated by in-plane loads, cord construction is a very nice way to make lightweight structures. The problem with cord construction is the core material that we use has much lower structural properties than the skins. And it's that connection between the core and the skins that can give us trouble. And that's called delamination or when the core debonds. So we want to make sure we've really paid good attention to making sure that core is adhered both to the skin we can't see, and in the case of open molding, we're doing a blind connection, or in the case of the core, we can see on top of the core when we're laminating over it. So we really want to make sure that we've got a good bond to the core, and we want to make sure that we haven't created any passageways where water can get in the core and saturate the core. This is really important for boats. Okay? So again, we always start at the beginning. We have to handle the materials properly. So the core materials need to be stored according to the manufacturer's recommendation. In particular, if you have a balsa core, that's a wood core, it's much more sensitive to moisture than a synthetic core like a foam core would be. So a balsa core would usually come wrapped in plastic, and it would be a great idea to store that in a more humidity-controlled environment. Okay. Now, the other part is handling the core in the factory. So more and more companies will kit their core up, all right? So it's been pre-cut and it's ready to go on the product, and it's either in a box or on a cart. What you want to make sure is that as you're handling that core, you're doing it in such a way that you're not putting any contaminants on the core. For example, it's common to dry fit the core before you install it. After you've put it on to make sure all the pieces fit, once you take it off, the last place you want to put it is on the factory floor, because that's full of contaminants. It's going to get stuck right to the core, and that's going to interfere with the bond of the core. Okay? So after we have the core on site, we need to check that skin, because we're going to bed the core onto the laminate in the case of open molding. Okay, so we don't want any standing fibers, we don't want any bumps. All right, we have to get a nice smooth laminate so that the core fits nicely up against the skin to give us a good bond. Okay? And then we're going to be bedding the core either with a bedding compound, as we'll talk about here, or we'll bed it with a composite material like chopped strand mat or a polyester mat. And these are common methods that we use to bed. The bedding layer is when we're putting the core down onto a skin in the open molding process. And it's a blind connection. We can't see through the core. Now, after we've bedded the core, we laminate over it. That's a little bit better situation because we can see that connection and make sure we don't have voids. All right. So what we really want is we need to make sure that core is intimately bonded to the skin in all the areas, and that gives us the critical link we need for our sandwich construction. Okay. And the core materials tend to be inch thick, half-inch thick, and you just can't take your laminate and come off that core, come down a 90-degree bend and tie into your laminate. So you always need these ramps. So you're going to either put putty ramps or kerfs, or they make triangle shapes of foam that can take your foam core and ramp it down to the laminate so you can avoid making a rough angle that's going to not be laminatable and have a lot of defects. So just a little bit on the philosophy of core. So what we're using core for is to improve our bending loads. So cores don't do much for us in the way of improving our in-plane loading properties, but they're very important for bending loads. And so we have two examples of cord constructions here and two different methods of doing it. So on the left, for both a sailboat and a powerboat, you kind of have the option of a fully cored structure. And on the right, you have a partially cored structure, all right? And in the fully cored structure, like here, let's just focus on the powerboat, the core is actually coming through the entire structure all the way down to the keel. Now, if you think about what core is for, it's for bending. And the keel actually forms a stiffened point, as do our stringers and our chine. So all of our bending loads are maximum in between these supports. As we move very close to the edge, we don't really need a core for bending loads. And in fact, by putting this here, we put a very large stress riser, which means we're going to have to make this area very, very strong because it's very stiff and it's going to attract load. Let's contrast to what's happening over here, where the core is there where the bending moments are large, and where there are not a lot of bending moments, the core tapers to a single skin. Okay, so if I'm over here pushing at this point, okay, I don't have much lever arm and I don't need much core, but when I'm over here pushing, now between these two supports, all right, that is the maximum bending moment for that area, and I've got my core there. Same thing here with the chine. I've gone to a solid glass, fiberglass chine, solid glass attachment to the hull. Okay, you can do the same in power and sail. And we recommend that you consider this as a really good technique, especially for boat construction, because this provides a really nice, tough, strong keel, a very strong connection to the side that's going to be tough and durable, and not prone to delamination in those areas because there's just no core there. Okay. All right. So we're going to get a little deeper into it, and we've got our skins and our core, and we've got to attach that core to the skin. We can do that with laminate. We can do it with putty, and those would be our open mode processes. And then we're going to be talking more about closed molding. And in closed molding, we put everything in dry, and then we're going to put a vacuum bag over the entire assembly of dry fabric and cores, and we're going to pull the resin in under vacuum. And we're going to get into that in quite a bit of detail in other sessions. Okay, so let's talk about putty first. So if we're using putty, what the most important thing is that we make sure that the putty has not cured before the core goes on there. Okay, so we need to mix up the putty, and we need to do a gel test to make sure we understand the gel time of the putty. Once we understand the gel time, that kind of gives us our workable area that we want to take on. So we don't want to put putty on too big an area that we don't have enough time to get the core on it, and we might even be vacuuming the core down to hold it. So we need to have enough time for all of that to happen, because if the putty cures before the core is on there, now you've got really big problems. Okay, so what we want is a nice consistent bond line between the core and the skin, whether that's chop mat or a bedding putty. All right, we don't want voids in the bond line. Those are going to be places where we're going to get failures. And we want the bedding material to generally cure with the core. So what we mean by that is the cores are first coated with a resin. So that's called priming. So you coat the resin onto the core, and then you take that now wet core with resin on it, and put it down into your bedding material. And that creates a nice connection between the putty and the core. Okay, so the priming is really important when you're using putties. If you're bedding with chop mat, it may not need to be used because you got a lot of resin that's going to come up through the bottom, through the layers of glass that you're using. Okay. Now, as you look at the core materials, you have a lot of choices of cores, and you want to pick the right kind of core for the right areas. So there are plain sheets. These are solid sheets, and they have little bleeder holes in them that are going to help you get the air out from underneath the bedding. Okay. Alternatively, you'll see curved sheets, scrim-backed cores, very common, contour cores. These cores have a fabric backing on the back that and it's all cut into little squares, cubes, that allow the core to contour to shape. Now, those cores are made to be used where you have contour. Okay, so there's not a lot of sense to put on a flat area to use the curved or contour core. You use the sheet core because that contour core has got all those slices in there. Now we either got to fill that with putty or resin, and if we don't, guess what it's going to get filled with? If it's a boat, it's going to get filled with water. Okay, so one way not to have all that is to go with the sheet cores. All right, before you do the product, you need to do a test panel, and you need to make sure everything works right. So you want to do the test off the part. get your processes figured out, and then implement that on the part. Paying attention to the size area that you're going to do, because you don't want to over putty an area and have a cure on you before the resin's down. If you're wet bagging, or sorry, if you're using a chop mat core bedding, all right, you also, depending on the core, may want to limit the amount of time that the resin is exposed to the core material. So some of the cores can get softened by the resin. So if you're doing a very long infusion, for example, and you have a 2 or 3 or 5 hour gel time, you might want to run a test first just to make sure that the core material is stable for that long as the resin cures. Okay. All right, so core materials, many of them are susceptible to water migration. In particular, you'll always get water migration if you have voids between the core and the skins. Okay, so we want to make sure that we seal the core, and where the water is going to get in can be anywhere, but the culprits are penetrations. So the owner installs a compass in the boat, puts a screw in. That's the place where water now can come in. If that core material hasn't been filled, that whole grid of the whole boat, I've seen it fill up with water. Okay, so wherever we've got penetrations, through holes, lights, patches, all that, we want to pay attention that we've sealed the core up nicely. Okay, so let's look at some cores. So the different types. So plain foam, we talked about that. That's going to be a sheet foam material, and then they'll add the bleeder holes. So plain foam, you would worry about air entrapment if you were using a vacuum process, for example. If you're going to laminate on top of the core, plain foam could be fine. So you could lay the foam down, laminate on top of it, flip it over, laminate on top of it. You wouldn't need any holes in that case. But in the case of the bedding and a part, right, we want the bleeder holes. Okay, and then you'll see various types of cores that are made to work for different situations. So a single cut core cuts halfway through the core, and it gives you some flexibility for bend in the core. Double cut, we're going to cut through both sides of the core. So these first started out as a way to make the core flexible without cutting all the way through. And as infusion, which we're going to talk about next, where we're sucking the resin in, these cut lines actually become very, very important because they become resin feeder lines built into the core system for the infusion process. So we'll talk a little more about that. Okay, so double cut has those lines on both sides so the core can flex, and then again giving you pathways for resin. And then there's the contour scrim core, which has a fabric backing, little square blocks attached to the glass, typically mostly used in hand layup. You can infuse it, but you're going to fill that grid pattern up with resin, and it's going to pretty much create a lot of print through, telegraphing, weight problems. Okay, all right. So a little more on core installation. We want to prepare the surface. We do that by making sure everything's smooth. If you hit it with the 80 grit sandpaper, that's great. If the laminate has been sitting for 3 or 4 days, you want to sand the entire surface because we're moving out of that primary bonding window. Okay, we have good chemical bonding for 3 to 4 days. After that, we're getting less chemical bonding, so we want to sand the surface. Okay, we also may want to sand the surface if we have standing fibers because we need a nice flat surface to bond the core on. Okay. And then after we've done that, we want to get the dust and dirt off of it. Okay, if we're going to spray it with air, we better be careful. We don't want to use compressed air that's got oil in it. All right, so if we're using compressed air, our air needs to be clean. It is wet. We don't want wet, we don't want oil. So you imagine you go through this whole process, sand the surface, use compressed air, air's got oil in it. What kind of bond do you think we're going to get to the core? We're not. The oil's going to act like a release agent. Okay, so you want to get rid of the dust in a proper way. You want to make sure the core all fits. Before you start the job, you don't want to be sitting there with wet resin and the core doesn't fit. So pre-cut, pre-fit the sheets, make sure everything lays out right, get your vacuum bag cut, all your materials ready. Of course, you've got a trained workforce, okay, to make sure they know what to do. Okay, and if you don't, you should practice on various size scales before going to the paid for part. Okay. Well, when you have cores, they come in sheets, so you're going to have to put sheets together. what you want is you don't want big gaps between the sheets. If there's a big gap between the sheet, the skin could buckle into that gap. So we want them to fit together nicely, okay? And if we're coming down where the core ends and we need to come down to a laminate, we want to put a bevel in it. We can either do a putty ramp, or we can cut the core, or we can put a little core wedge in there that they sell just for that. Okay, so we're trying to avoid making that 90-degree bend around the corner because composites just don't like that. Okay, so we're going to use chop strand mat now for the core bedding in this case. So we're going to apply chop strand mat. We're going to be back to our high resin content laminate, right? We want 80% resin here, like especially if it's balsa core, it's going to suck up some resin. So we're going to go with a very high resin content to make sure we got plenty of resin for bedding the core. Okay, we're going to chop the glass and we're going to roll it out. So it's not good enough just to put the chop on. We've got to get the air out of that laminate. We're going to roll it out. Okay, so 1.5 ounces is typical. It can be more depending on the laminate schedule. All right, you want to roll it out, get all the air out, and make sure your gel time is such that you got time to get the core down and bedded. Okay, we talked about the higher resin weight. So now that you've got the core down on the part, one thing you don't want to do is press really hard on it and then take that pressure off. So if you manage to position it such that now you've got to step on the core to get out of the product, to get out of the way. Once you step on it, you're going to squish all that resin out of the core. And when you take your foot off, guess what's going to replace that resin? Yep, air. So look at how you're staging it so you can avoid walking on any of the cores. Okay, if you need to put pressure on it, you got long rollers that you can use with handles. Okay, and then as we talk next, one of the best ways to bed core is going to be with a vacuum. All right, now in the open mold process, all right, we have bedded the core either in putty or in chop mat. The core is bare on top. Okay, so now that before we laminate over the core, that's the time we would come in, knock out any resin that piled up or got sucked up there. We would then put our putty ramps or fillets or grind the core for ramps. Okay, and this is a great time to check your core to make sure it's bonded. Okay, so at this point you could feel it. If the core is loose, you have not bedded it well, you would want to cut that area of core out and rebed it. All right, so this is great. If you can catch it now, it's going to be a real saver in time and money, because if you don't catch it now, you're not going to see it till it's out in the field and you're looking at what could be a very, very expensive repair trying to get to the core in a structure like a boat. Okay, so tap test, feel it, twist the cores. You can tell if it's bonded. Okay, now once we've checked that, we want to make sure the top surface is ready for lamination. So one good thing I like, if it's a contour core, you can remove the scrim material and sand it. You don't need that scrim anymore. If you look in the lab when we do testing, often we see the laminate fail. When we pull these apart in a test, the scrim side tends to fail more than the bedding side. Well, we pay a lot of attention to the bedding side because it's the blind connection. Then we laminate over the scrim. If you remove the scrim, you get a little bit better bond, and it's worth it. Okay, so make sure that your edges are good. Okay, if you've got ramps, corners, things like that, you can use putties, you can sand them, or you could again use those wedges we talked about. Okay, now going to bedding compound in place of a chop mat to bed, you want to pick the right bedding compound for your temperature and your shop conditions. So we'll have different gel times, okay? And this block method is by one of the core manufacturers, and it works for all of them. So they want you to do a test off the part. So small blocks of core, we hot coat them with resin, and then we put putty onto a laminate surface, and the gel time is at least 40 minutes, so we wait 30 minutes, and after 30 minutes we start twisting the block, okay? And you'll feel it when the resin starts to gel, the block won't turn easily. That is the working time that you have to get the core in. So that gives you your mindset to think about how big an area can I do. So as the guys putty it, they stop, or another crew is following behind adding the core. Okay. You want to put the core on a few ways to do it. There are spray methods, in which case you would spray much like we would do our controlled spraying. Follow that same process, checking with a mill gauge. Or you can use a V-notch trowel like you would use for laying tile. That works just fine too. All right, great. We've given you some of the basics of sandwich construction and more exciting subject matter to come.